Harley, close the door for me, please. What in the world? Why is it not projecting? That's strange.
What's a gray hair? What's a gray hair? That's cool. Go ahead.
All right, that's better. All right, hush, please. In general, I was very happy with the results on it. Did anybody? I don't think anybody got a perfect grade.
Anybody get a back grade?
Oh, yeah.
Plus.
But for the most part, you guys did a fine job. All right. Lily?
She's living.
I know you're a perfectionist, Lily. Joe's here today? No. Chris?
Oh, I'm so good.
Okay.
No. Best grade I've had.
Oh, no. I know what Hannah's doing. He's learning
Oh.
Joe thinks it's funny.
Such a bad start.
Just sketching the line, that was the easy part.
Look at me. You got 1 point higher than me.
What you guys get? What you guys get?
I got 38.
You got 38?
No, you got the highest out of it. I got the lowest. I got 38.
Show me.
Why is it like this? I did this straight line. I read 39. Negative something on. I did that before.
You guys need to have 39. It's all those minus words I could steal.
Like shooting
39.
I only got 2 minus words I got 30. You got 4 of yourself.
Hey, put on the back. Not on the back.
Yikes, Santa. What happened?
What'd you get? Oh,
Oh,
Everybody's got one, yes? All right. I don't think I need to go over this because it's pretty clear what you made. For the most part, I was surprised nobody got a perfect paper, but I was surprised. No, I was happy, not surprised. I was surprised that nobody got a perfect paper. I was happy that we did well. And for the most people that got 37, 38, 39, you can see your silly mistake. So, there's nothing I can do to keep you from making a silly mistake other than try to at times tell you some little tricks of, hey, look at the line first, determine whether it's positive or negative slope, then do the calculation. And that way, if you come up with 2 instead of -2, when it's a negative slope, you can keep yourself from making that silly mistake. I was impressed because for the most part, number 10 was the one that required the most work, and you guys did pretty good on that, most of you. Some of you had a silly algebra mistake, and it literally threw you off, but you had the procedure down cold. I mean, like you knew what to do. There was only 1 or 2 of you that had no clue what you're doing there.
I didn't have it.
And I know how many times I stomped the floor and said, hey, horizontal, vertical line, and yet still some of you refused to write on a sheet of paper that, what the slope is and what it looks like and how you graph it and how you write it. So I had a couple people miss those silly mistakes. But other than that, I was pretty happy with it. All right, moving on. Hey, this is the last. Oh, by the way, if you did well on this, chances are, if you got an A on this, chances are you're going to get an A on the test because the test, this is 80% of the test right here. 80% of the test. All right. So that's a good thing. Last thing, and I like this class. I'm talking about you. I like this class, the one I'm about to teach you. It's fun and it's super simple. And boy, do I get kids that get lost. And I know why. I mean, there's your homework. Kids get lost on this because they don't pay attention. It has nothing to do that this is crazy complicated. I don't get it. It's nothing like this. It's that when I'm teaching the class, some kids will kind of zone out or they won't ask a question if they are lost. Then they get home and like, I don't know, it's got these weird things on it. I don't even know what it means. So as I teach the class, make sure that you are asking questions. If I say anything, you're like, I don't get what you're saying, you ask that question. Trust me when I say what we're about to do is ridiculously easy. There's nothing hard to it, but you know, some kids get lost. Did I not print out? No, I did. Some kids get lost on this, and it's just way too easy to get lost on. When I'm teaching it, certainly you can get lost on a couple things, but in terms of if you pay attention, ask questions, you'll get it. Trust me, you will get it.
Why is there so many white spots?
All right. I am almost 100% sure. Brady, you ever done function notation before? Okay, I am pretty confident that none of you have seen anything that I'm about to show you. So this is brand new, and you just gotta trust me when I say it's easy, because it is. Here we go. I will collect homework at the end of class. And I had to clear that question. All right. Everybody have the homework written down?
Maybe. Yes.
All right. This one is, like I said, it's, if you just give me half your attention, just hang it up. You give me your full attention, halfway through the class, you're like, oh God, this is easy. Why is he making such a big deal out of that? All right, here we go. Functions. Once you get past geometry, everything's functions. Everything in math is functions. 99.9% is a function. All right, we're going to start by talking about something called a relation. In math, this has a meaning, a definition. Here's a relationship. Soup.
Yeah.
Cans of soup.
Yeah.
Typically, many schools every year they do, you know, a food drive for the poor, right? They say, all right, guys, which homeroom has the most soup cans wins a pizza party, something like that. Okay. So when I actually made this particular slide, I don't know, 10 years ago, we were in a food drive, and I literally just counted up, hey, how many cans did this one class bring in? So here was my data from that. I taught 4 classes and number of students in each class and how many cans each class. I literally just made the
Class 4 is try hard.
Right. They really wanted
give
pizza.
100.
All right. So here is the data. This big term relations, it just simply means you determine what number is related to another number. In other words, I determine the relationship. I'm going to relate 2 numbers together. I'm going to relate this number to this number. What does that mean? It means literally what I just said. I'm going to relate this number to this number. That means these 2 numbers are now paired together. I'm not talking about adding, subtracting, multiplying, dividing. I'm just saying these 2 numbers now for eternity go together. 25, 95. That's the relationship. The relationship is the number of students for the number of cans. Well, that relationship would carry through to the entire table. That number is now paired to this number is paired to this number, this number. That's my relationship. I equally could have done it the other way. I could have paired this number to that number. I'll just find that relationship. Relationship is now odd class to even class. There's another relationship. Point being is relationship is not a crazy hard to understand concept. It's just I take 2 numbers and say they are related. The only way this makes sense is relate the number of students in a particular class to the number of cans. That would be the smart relationship. Okay, so I'm going to relate the number of students to the number of cans. Great, that's those 2 numbers. I give you 2 numbers, hint, hint, suspiciously in this chapter, what do you do with 2 numbers?
Divide.
Not in this chapter.
Add.
So this entire
Plus.
chapter we've been, if I gave you 2
Plus.
numbers, we
Put 'em on the graph.
put them on a graph, right? We wrote them as an ordered pair. X comma Y. That's what a relationship is. A relationship is saying one number goes here, one number goes there. It's an ordered pair. It's not a hard thing to wrap your head around. I have 1, 2, 3, 4 points. Okay, the first or the second one after relationship. The second thing is this. I now have a collection of points. Not to graph them, but to put them together. I will write them from left to right, and I'm going to put braces around them. See what I did? That is the relation. Okay? That is the relation. Okay? The only thing these braces do, it says that all of these have the same relationship. Number of students to the number of cans. All right, is that a hard concept? And if you can look forward on your sheet, you can see, hey, a whole bunch of relations kind of floating around. All right, so that's a relationship. Write this down, box 1. A relation is just a set of ordered pairs. By set, I mean it's going to have at least a couple, right? Technically, a set could be empty. That's called literally called
guess
empty.
what we're doing today?
What?
Okay, so we're trying to find which one's actually compatible together.
No.
Dang it. No.
If it were that easy, it is easy, but it's not that easy. All right, so it's just a set of ordered pairs. Hey, here is a relation. I'm relating the number 18 to the number 100. Typically, when you have a relation, it means something. The number of students that, or sorry, the number of buses it takes to, I don't know, short buses it takes to move 100 students, right? Okay. That's a relation. It's just that. When you have more than one, well, then you put them together, separated by commas and braces on the end. The braces just simply mean all of these have the same relationship. So this number pairs with that number based upon whatever your established set of rules for a relation is. Okay, well, that one isn't very hard to wrap your head around. Yes? You're like, well, do you want me to graph this? Okay, hold your roll for a second. We'll talk about that later. All right, now here's where Algebra 1 gets ugly. And this is where, if you're not paying attention, you won't get this. Okay? So it turns out that relations come in 2 flavors, right?
X and Y.
No.
Y and X.
Individual part of my set, just one of those points, clearly an X and a Y. When it's a relation, and you're talking about all the relations, right? The list of inside your braces, we call all the X values a name. We call all the Y values a name. It's just a name. The name means the X values. The other name means the Y values. Is everybody paying attention? So if you can look, you don't have to look at box 4 right now, but box 4, there's a relation, right? It's ordered pairs separated by braces. If I take all the X values together, has anybody ever heard this? They are called the, starts with the, wouldn't that make sense? They don't. They use the D word. They are called the domain. You need to write that down.
That was a lot of work.
The domain is when you have a relation and you just look at the X values. That's called the domain. Anyone ever heard that word before?
No, I've heard Dominion Republic.
Domain is just all the X values of the relation. You got that look on your face. You got the I'm lost already look. Yes or no? Good, then that's the look I want on your face. We do the same thing to the Y values. You take your relation and we pluck off all the Y values, we give them a name. Anybody know? They are called the range. Why did they pick these 2 words? Oh, that's lost to me. But those are the 2 words. I will have kids in high school get to senior year and like, I don't know what a domain is. A domain are just the X values. They'll say, I don't know what the range, what are you asking for? What is this range thing? It's just the Y values. Hey, if my set is just this one point, the domain is 18 and the range is 100. That's it. When I give you multiple sets or multiple points in that set, it's all the X values of the domain and all the Y values of the range. I said it's ugly because, all right, if you don't get the instruction, then you say, what's the domain? You're like, I have no idea. If I say, what are the X values? Well, okay, maybe there's a chance there. So why don't we say all the X values? Yeah, that's why this is ugly. I don't know, maybe we're purposely trying to trick people. Domain and range, questions. Oh, by the way, the hardest thing in high school when you first encounter this is remember which is which. X comes before Y, alphabetically. Domain comes before range. That's how I remembered it. I couldn't remember which is the domain and range. I knew they were called domain and range, but I could remember. I would always forget which is the X, which is Y, till someone said, "Hey, they're alphabetical." Yeah.
That'd be a question on test.
I'm going to say, show me the domain. You have to list the domain. You have to pull out all the X values. Okay. All right. Easy enough. I said relations come in 2 flavors. This is the ugly part again. Relations come in 2 flavors. Not good relationship, bad relationship. But they come in something called a function. And the other one's going to be called a You're either a function or you're not a function, right? You're either in the function club or you're not in the function club,
That's functionist.
right? So relations come in two flavors. Functions, all are relations, but we're going to have this flavor called functions and not functions. Primarily, I don't know, it's close to 99% of all high school math deals with functions. There are some that are not. You'll see a couple today that are not functions, and you get a little bit of it. Geometry, you get a lot of non-functions in geometry, but algebra 2, pre-calculus, calculus, it's almost all functions. Almost. Okay, we okay with that idea? I haven't defined what a function is yet. I have defined what a relationship is, the number of students to the number of cans. You get to define that. Okay? All right, it's going to get ugly. All right, write this down, please. Don't worry about what it says, just write it down. As we progress through the class, this definition will make more and more sense. If you are a function, that is a relation. Remember, all functions are relations. That is a relation in which each member of the domain, that's why I define domain, that's the x values, is paired, not one, exactly one member of the range. You're married with two, you're not a function. You have to be married with exactly one member of the range. A relation is which each member of the domain is paired with exactly one member of the range. That is called a function.
The true question is, how am I going to use this in the real world?
I'll show you. Okay. I literally have a real world definition here coming up like within 2 minutes. All right, so these are called functions. Now, you may not understand what any of that means. You wrote the words down, but I will show you what it means. Okay? We good? Everybody has it written down? All right, here we go. If you wanted real world, here's real world. All right, what is that?
Pepsi.
You know I always drink Diet Pepsi. Okay, so there's a Pepsi machine, right? We use in the real world the idea that the machine is functioning, yes? It's the same thing in math. If it is functioning, we know what happens with soda machines. In math, the word function has the same meaning. Watch this, Rylan. Okay? Ignore the fact that you put money in it. Remember the fact that once the money is in, you press buttons. If the machine is functioning, when I press the Diet Pepsi button, what happens?
Gives you that Pepsi.
Okay.
Falls in the face of the machine.
Now let's relate this to the math. The math, we have our domain. Our domain are the x values. The x values are your inputs. Your inputs are the buttons of the machine. You input, right? I press the button, right? Those are called the domain or the x values. Well, what's the y values then, or the range? What happens when you press the button?
It goes down.
If the machine is functioning and I press the Diet Pepsi button,
It gives you Diet Pepsi.
I get a range of a Diet Pepsi.
That's an old Diet Pepsi cup.
It is, because this is an old class. This is probably 12 years old. Now let's look at the definition. Now it will make sense. A relation or function is a relation in which each member of the domain only goes to one. I don't mean one Pepsi comes out. I mean, when I press this button, the only thing I ever get out is a
Diet Pepsi.
And if that is what's happening, I say, ooh, I got my Diet Pepsi. The machine is functioning. What's a non-functioning machine?
Something that gives me a Sprite when I order for a Diet Pepsi.
Non-functions. The machine is broken. It's not functioning. I press the Diet Pepsi once, and the guy in front of me gets a
Coca-Cola.
no, he gets a Diet Pepsi. So I'm like, oh, it's a functioning machine. I go up there, I press the button, I get a
7-Up. Oh, let's go! I guessed it.
well, I had 7-Up written right there.
Yeah, but he's the that between something is a 50%
All right.
chance.
We would say that the machine isn't functioning. Now let's look at the definition again. The definition says it's a function if every time I press the Diet Pepsi, one thing happens. A Diet Pepsi. Two people just pressed this button. One time we got a 7-Up and one time we got a Diet Pepsi. That's two things for one button. That machine's broken. It's not functioning. In math, that's what it means. That's the real world application. In math, you are a function if every x only goes to one y. You are not a function if the x goes to, sometimes it goes to one number, sometimes it goes to another number. And that can happen. Like we have non-functions in math, just like we have non-functioning machines.
Seems more like a real world. Like this seems more like not math, but just common knowledge.
It is. Okay, so here we go. So what are you going to ask me tonight for homework? Well, what I'm going to ask you is I'm going to give you a relation. First thing you're going to ask you, is it a function? So I'm going to give you a relation. It's a relation. It's got domains, x, 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 x. It's got range, y, 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 y. You have to figure out if this machine is working.
How am I going to do that?
So here's what you do. You ready?
Mm-hmm.
It's a machine, or it's a functioning machine if every x only goes to one number. Let's see if that's true. What's the domain here?
1.
0, 1, 2, 3.
Okay. If I were to write the domain, I would write 0, 1, 2, 3. It's just the x values. You got that look again. Okay. I'm just picking out the x values, yes?
Mm-hmm.
The range is the,
Y.
so I'm going to pull out the y values. What are the y values?
1, 2, 3, 4.
Okay. The relationship joins the numbers together. This says 0 goes to what? This is the relation. 0 goes to,
1.
so 0 goes to 1. If I press this button, what comes out? 1.
1.
1 goes to, if I press this button, one number comes out, 2. If I press this button, one number comes out, 3. If I press this button,
3.
was there any button that I pressed where more than one number came out? You were like, well, what would that look like? By the way, that's a function. A function is where every number over here only has one arrow coming from it. Okay? This whole thing is called a mapping diagram. Tonight we'll say make a mapping diagram. Here's your mapping diagram. Okay? Here's a non-function. What's the domain?
0, 1, 1, 3.
And you don't have to write repeats, so it's 0, 1, 3, right? So the domain or the x values 0, 1, and 3, right? Okay, the range are
1, 2, 3, 4.
okay, the range are just the y values. Now let's see what the relationship. 0 goes to, okay, I press 0, I get 1. 1 goes to, 1 goes to, wait a minute. One time when I pressed 1, what came out?
3.
And the other time I pressed it, it says it's a function if every member of the domain only goes to one number. Here's a problem. 1 goes to 2 numbers.
So if there's
Not a function.
But isn't there 2 ones?
No, 1 is still 1, right? It's still the same button. 1 is 1, right? It's like saying you have a, Sprite, Diet Pepsi, Coke button, right? If I press the Diet Pepsi button right here, one time it gave me a Diet Pepsi and one time it gave me a 7-Up.
50% chance of being a
Give me my money back, right?
Unless you get the
So this is the machine where you press the button, you don't get what you want. Sometimes. Not functioning. The machine's broken. So this is an example mathematically of a non-function.
What about the other one?
Yeah, but 1 is still the same. The domain is still 0, 1, 3. I mean, the fact that you have 2 of them, it's still, you have a number 1. Okay? This is what it will look like when it's a non-function. This is what it will look like when it, too many clicks. This is what it will look like when it's a function. You'll only have one arrow coming from every one of these numbers of the domain. So guess what you got to do tonight for homework?
Find out which one's not the
You got to do this. This is called a mapping diagram. Hold your thought. I know what you're about to say. Okay. So that's what we have to do. Let's do one. All right. Box number, I don't know. I lied. I didn't have you do this. All right. Hold your thought. And I will call on you. The domain here is what?
1, 2, 3.
0, 1, 2, 3.
0 is technically not a number.
Yes, it is a number.
It has no value.
It's still a number.
How is that possible? It has
All right.
no value. Why is it a number?
Here we go. What are the range here?
1, 1, 2, 2.
Well, just 1 and 2, right? So here we go. Let's see if it's a function. 0 goes to 1 goes to 1, 2 goes to 2, and 3 goes. Is this a function?
No.
All right. When I press button this, do I get 1 or 2 things?
1.
When I press button this, do I get 1 or 2 things?
1.
When I press button this, do I get 1 or 2 things? Each time I press a button, how many things happen? That's the definition, exactly 1. You can have one arrow coming from the domain. Is this a machine in real life? Yes, it's a Coke machine that has 2 Pepsi buttons. The first button says Pepsi, the second button says Pepsi.
This is scuffed already. Coke would not have a Pepsi in the Coke machine.
I said Pepsi, not
No,
Coke.
you said Coke, and then you said there'd be Pepsi.
The previous one I did say Coke, and I realized that somebody's going to call me on that. In my old school, we had a machine that literally had nothing but water buttons. And I would always say, hey, this is the machine that has this is the machine in the cafeteria.
That's really
All right.
sucks.
But yeah, that's still a functioning machine. You can still have 2 buttons that give you the same product. All right. Rowan, function, not a function. Okay, how is Rowan doing this without a mapping diagram? All right.
It's a Y.
Oh, function, not a function.
Function.
That's a function. Oh, that's ugly.
That's weird.
I made this literally year 1. That's why it's got weird animation. I don't do this animation ever again. Function, not a function.
Not a function.
Why is this one not a function?
Because 0 goes to 3.
Because one member of the domain goes to 2 different numbers. Now, as all of you said, this mapping diagram is great, it works, but there's way easier. The way easier method is to do what? And see if there are repeats. And yes, that's the easy way to do this. So functions are relations that have no repeats in the domain. That means the x value. There's no repeated x. You can have repeated y's. That's the machine that there's multiple buttons that give you Pepsi, right? But you can't have any repeats in the domain, right? Or x values. So absolutely 100%. Do you have to do a mapping diagram? I'm going to say no, even if the book says so. Right? If it says do a mapping diagram, I'm okay with you saying, well, I can do this without a mapping diagram. If you're a non-function, that means you have repeats in the x values, the domain. You're already doing high-level math right now. We're using the word domain, function. You didn't know what the heck that was when you walked in my class. Now you do. Is that true?
I knew what a function was because
Okay.
it's function.
All right, so let's do this real quick. Function, not a function.
No.
Kale, you know what we're doing?
No.
Function, not a function.
No.
I heard no and yes. Are there any repeats in the x's?
No.
If there are no repeats, it's a function. Okay? If there's no repeats, it's a function. If there are repeats, and we're looking at x's, not y's, if there are repeats, not a function. Function, not a function. I got 2 negative 1s in my x values. Not a function. Can you do this by yourself now? Easy or hard? I told you today was easy if you paid attention, and luckily you're paying attention. All right, do we need to do more of this or we got this? All right, Kaylee, function, not a function, first one. Say again? Why? The repeats can be in the y values, but they can't be in the x values. Are there repeated x's? So this one is a function. Aiden, function, not a function. We can have repeats in the x's, but we can't have repeats in the, I said that backwards. We can have repeats in the y's, the range, but we can't have repeats in the x values, not a function. We would say repeats in the domain. Function, not a function. That last one's a function. We got it? All right. 3 things. Whew. All right, there's a second method of doing this. Do not do this method unless they give you a graph. Do not do this method unless they give you a graph. If they give you a graph and they say, here is the relationship, is it a function? Use this method. If they give you this, do not use this method. Use this method. Right? But if they give you a graph, oh, absolutely use the second method. You ready? What will happen if we graph these points?
They come out as point.
What would happen if we graph these points? And no, it may or may not make a line. We're going to get a specific shape for non-functions and a specific shape for functions. Okay? Now let's investigate that. Once again, if they give you this, I don't care if they even tell you to use this thing, which I'm about to tell you what it is. Don't do it. You don't. if they give you a graph, use it. It makes sense, but not if they give you the relation. Oh, first off, function, not a function.
No.
Function, not a function.
Yes.
It is a function, right? We have repeats in the range, but no repeats in the domain. If I were to graph those 3 points, it would look like this, yes? If I took a vertical line, here's my vertical line. No, opposite of that. If I took a vertical line, hence the name vertical line test, and as I go from the left to the right, you could also go right to left, how many points do I ever touch?
1, 2.
I'm touching 2 points right now?
No, I'm counting 1.
I can only ever, when it's a function, touch 1 point. Do you see that? I mean, that are graph, correct?
I thought the dots were like the numbers.
The dots are these 3 points.
Yeah, but I thought like the numbers on the line were dots.
Oh, gotcha. Okay.
And then it's not a function if there are more than one dot.
So this is the non-function, right? We have a repeated domain. We got what? 2 2s right here. We got repeated x's. So here's a picture of a non-function. What happens? How many points? I go from left to right. How many points am I touching? How many points am I touching? Where do you see 2 points? Agreed. How many points am I touching?
3.
How many points am I touching?
2.
If you ever touch 2 or more, not a function. So this is what, it doesn't make a line, could make a line. What it does is it gives you 2 points, since they have the same x values. Remember, this is where x lives. You wind up with 2 vertical points. I'm going to go back to my previous statement. What did I say when you're going to use this? If they give you a graph, use the vertical line test. If they give you this, it's ridiculous, right? Why would you go to the effort of graphing it? But if they give you a graph, absolutely use the vertical line test. As you go higher, algebra 2, pre-calculus, calculus, we use the vertical line test because most of the time you got a graphing calculator. You graph it. Is it a function? I don't know. Let me graph it. Function, not a function. Looking at the graph. How do you know? Notice as I go from left, and it can be right to left, I'm only touching 1 point, the red one, the blue one, the green one, the whatever color that is.
Purple.
All right. I always want to say blue. If they give you this, should you graph it? Don't graph it. Just look at it. Not a function. Is there anyone lost on the magic that we're doing here? Function, not a function. Porter, you got this? Piper? As you look from left to right, just at the x's, are there any repeated x's? That's why it's not a function. If you had done a graph and it had repeated x values, you'd get 2 points that make a vertical line, not a function. If it looks like this, I mean, there's dots here, but as we go with a vertical line, hence the name vertical line test, we're only touching 1 point, 1 point, 1 point, 1 point. Okay, enough of that. This is how you use it in higher level math. Hey, what's that shape? There is an equation for circles. X squared plus y squared equals r squared. That's the equation of a circle. Are circles functions? I can have an equation for it, doesn't make a function. Why? I'm touching that point and that point at the same time, not a function. These are parabolas, x squared, or y equals x squared. Function, not a function.
Function.
Turns out that parabolas are functions. I'm only touching 1 point, only touching 1 point. No matter where I go, I can only touch 1 point. Sideways parabola, not a function, right? Even the y-axis touches 2 points, okay? Cool. Not a function, function, function. Not a function, sorry. Last thing. Woo, all right. Vertical line test is easy. I never had kids not understand it. If you've been paying attention, we're good to go. Now, the last thing is the ugliest of the ugly. You ready? There is a notation. A notation just means symbols that we use to do what we've done before. Not what we've done today, but what we've done in this chapter, the very first section. If you remember the first section, what we did was this. I gave you an equation. Remember, this was literally 8.1. I gave you an equation. I had 1y, 1x. They were to the first power, so it's linear. And then what I did was, remember, linear equations except for vertical lines, right? vertical lines are the form of x equals k. I gave you a value for x. Let's say, I don't know, 3. Remember, we've done these before. These are quadratics. You see that looking weird thing? That's what we're about to do. I'm going to use that notation right there and explain what it means. This says 2x plus 4. What's that say? These are the same. These are literally the same. It's just that this y now becomes this notation right here. Why do you do that? Because linear equations are functions. Linear equations are functions because they pass a vertical line test, with exception of a vertical line. Think about it. If I draw a line and I draw another line that's vertical, how many places do I touch as I go from left to right? One at a time, though. Therefore, it passes the vertical line test. So all linear equations are functions. If you are a function, you get to use what's called function notation. Don't get lost on this. It's just that this y now turns into this weird looking thing, a weird looking f and an x with parentheses around it. All right, now let me explain what's going on. By the way, if you're quadratic and you're a function, you get to use function notation as well too. Anytime you're a function, you get to use this thing called function. Now f, yes, f stands for function, but it could be any letter of the alphabet. You could have z of x. You could have t of x. You won't have x of x, but any letter. All right, so what does this mean? Box 9, write both of these down. What? Write both of these down. We've already explained that all linear equations are functions with exception of vertical lines. So x equals k doesn't get to play with us in this case. But y equals mx plus b, that's a function. If it's a function, we get to use this thing called function notation. That thing right there. I got an f, I got an open parentheses, an x, and a closed parentheses. Here's the deal. It's called function notation, and all it means, it's read, oh, by the way, of f, not times x, f of x. If that was a g, it would be g of x. So it's read f of x. It doesn't mean f times x. It looks like it means that way, but it doesn't. And by the way, this f is a really weird looking f too. Whenever you see function notation, it's going to be italicized. It won't be cursive, but it'll be italicized. It will be very different than these other fonts that they use for the numbers and the letters. It'll be very clear to you that it's function notation. So what does it all mean? Here's what it means. Recall that if I give you a linear equation and I tell you a value for x, right? If I say if x is equal to 3, you can take this 3, plug it into x, do a little bit of math. 2 times 3 plus 4, we get y is equal to 10. And what you did in section number 1, you said that when x is 3, y is, and you wrote that as an ordered pair. Remember doing that? We're going to do the same thing with function notation. Literally, we're going to do the same thing with function notation. I'm going to give you a value for x. You're going to plug it in wherever you see an x, do the math, and write the ordered pair. Except it's going to have function notation. That's where I typically lose some kids. They're like, I don't know what it means. We're going to do what we did in section 8.1. So take a deep breath. Don't panic. I'll walk you through it. This is called evaluating functions. It's literally what we did in 8.1, except we said it, we called it evaluating equations. Now we're going to say evaluating functions. There's my new function. It's the same one. It's just instead of y, they put f of x. So this whole thing, f of x is just the letter. It's just the letter. That whole thing is just the letter y. Why are you making my life complicated? Because as soon as you see f of x, they are telling you it is a function. You don't have to do a vertical line test. You don't have to do a mapping diagram. They are telling you, if you see this, hey, this sucker's a function. You get more stuff as you get into higher level math of if it is a function. Right now, it's a function. So here's what we do. Before, we wrote, let's let x equals 3. That's what that means. That means take the function f and let x be the value 3. You see that? If x is equal to 3, I go to this side, and wherever I put an x, I write a, and that's what I'm going to do. So it basically is the same thing. What would y be if we let x be the value 3? So if I let f, take the function f, and let x be the value 3, I rewrite this portion, and I just let x be 3. It's literally the same thing. Kids get really hung up on this. Just let x be 3 on this side. Guess what? We're still going to get 10. So we say f of 3 is equal to 10. Guess what this really means? If this whole thing is y, that we're saying that when x is 3, y is, it's the whole ordered pair, that one little thing. When x is 3, y is 10. But remember, this whole thing means the letter y, so that literally means y equals 10. What's inside the parentheses is the x value. So it's still 310. Now, kids can get, I understand the first time you see it, it's confusing. So let's do some. What are we really doing? We're doing what we did in 8.1. All right, so here's how it works. Oh, quadratic. Here's my new function, p of x. P of x is 2x squared minus 3. They will ask you to evaluate it for a number. For instance, -3. So they're asking you to plug in -3 anywhere you see an x. So what do? Well, you simply rewrite this portion of it on this side and plug in -3 for x. Remember, when we plug in -3, we put parentheses. What's -3 squared? Not 6. 9, right? -3 times -3 is positive 9. 2 times 9 is, and 18 minus 3 is. So p of -3 is 15. What does this really mean? When x is -3, y is, and that's it. By the way, this is the answer in yellow using function notation. I don't have to rewrite the ordered pair because this is the ordered pair, x, y. Yes? Nobody's eyes are rolling back in their head? Rowan, I can't tell because your head's down. All right, box 10, grab your pencils. Let's do this one. What in the world are they asking me to do? They're asking me to do 2 evaluation for the function g. They're saying do it once when x is the value, and do it a second time when x is, so it's 2 questions here. One at a time. So I'm going to rewrite this thing. I'm going to let g, x be -2. So g of -2, I rewrite this portion of it, and I let x be -2. I'm going to pause to make sure that Chris is writing this down. But the cool thing is that you've already done this. You've already done the hardest part, which is the evaluation part. The only weird thing you got to wrap your head around is this weird looking thing that doesn't mean g times -2. Negative times a negative. So that's 8 plus 6, which is, and you're done. That is literally the answer. G of -2 is 14. Now it's an ordered pair. -2 is your x and 14 is your y. So if we had to graph it, we could. They're not going to ask you to graph it. They're going to say evaluate it. Let's do it now for 0. So all we do is we do g of 0. Anytime we see the letter x, we let x be the value 0. Brown.
Yes.
Pencil, move it.
Okay. Yeah.
-4 times 0?
0.
Plus 6?
6.
So g of 0 is 6, and you're done. What does this really mean? It means 0, 6 is the point. All right, you got to tell me who's lost. It shouldn't be. Like I said, it's not a hard class today, but it's definitely all new, and it's weird. Functions are just the way math goes from now on. Geometry, you don't see functions, but Algebra 2 pre-calculus, which you guys will probably all take, does involve functions every day. All right, remember it can be any letter. And oh, by the way, this can also be any letter. And if this letter instead of an X was a T, you'll see this a lot. Guess what that's going to be? It's going to be a T. You'll see this in science class all the time. C of T, because T represents time. So they love that function of time in their equations. All right, in order to do this, simply plug in 4 for anywhere I see an X. I see an X, I put parentheses. PEMDAS says we got to do exponents first. 4 squared is, and 3 times 16. Stop me if I'm going too fast. Therefore, C of 4 is pretty simple. Sophia, yes? You sure? Will this be on the test? Absolutely. So for those of you that need on your resource card, don't lose this homework. Yeah. It is, but guess what? I'm not going to have any 8.1 on it. I'm going to have this on it. Because if you can do this, you're doing 8.1. 8.1 was literally just evaluate a linear equation. And then we went to plotting points and then slope intercept form. And then we did scatter plots and then this. All right, C of -1. Anytime I see an X, I put a -1. If you're going to make a mistake, it's always going to be when there are negatives involved. -1 squared is, Rylan.
-1 squared. What?
You said it.
-1 squared.
Is?
+1.
And 3 times +1.
3.
Therefore, the answer is?
C, -1 C equals 2. I'm at 1.
You got it.
See, aha, didn't even need to be awake. Boom, I'm so good at this class.
I'm going to put a montage together of you saying silly things or something.
Like how?
Every class has been recorded. They're all on YouTube right now. From the start of the year.
Without my consent?
Without your consent, because your
That's
parents,
illegal.
when your parents signed the thing,
Well, they didn't give my permission to sign that.
that's why they're called your guardians.
Oh my God.
Until you reach the age of 18, well, actually in the state of Colorado, I think you can sue for emancipation 16, something like that.
If I hate my parents that much.
Yeah, don't do that because your parents give you food, love, and place to sleep. All right, homework, give it to me.
What's
There you
homework?
go.
Order? No homework?
No.
How come you didn't come to me during student advisement? That's good. Really, yes or no?
Oh, it would be this.
Thank you very much. Yes. Donka means thanks. They don't say thank you. They say Donka Sherman, which means thanks a lot. Thanks for the Nobody got it? Yes or no? All right, e-learners. Josie, are you online?
Justine never watches them live.
Haley, you live? Is anyone out there? Someone is. It's Julie. Questions, Julie? Julie's been having problems with her audio on her computer. All right. Got any questions? Chat me up tonight. See you tomorrow.